Alright, welcome to today's lesson, and today we are going to talk about the Anova and how it is used in hypothesis testing, and we also try and solve this particular problem here. So I'm Boydo Kanrindo, a third year student of Mathematics K University. So please don't forget to like the video and please help us by subscribing to our YouTube channel. Thank you very much. So the question here says, suppose the Ghana Safety Board wants to examine the safety of the following cars. We have hatchback, minivan, and sedan. It collects a sample of 3 for each of the treatments, that's the car types. Using the hypothetical data provided below, we are to test whether the mean pressure applied to the driver's head during a crash test is equal for each types of car, and we are to use a significance level of 5% or 0.05. So these are the 3 treatments: the hatchback, minivan, and sedan. And these are the 3 samples for each of them. So in all, we have 9 samples. So our n is 3 and our key, which is the number of treatments, is no. So our n is 9 and our key, which is the number of treatments, is 3. Alright. So the question says we should state the null and alternative hypothesis, calculate the appropriate test statistic, and obtain a critical value, state a decision rule, and interpret our results. So let's solve our question. So we are going to state a null and alternative hypothesis. So we will get it from here. It says using the hypothetical data provided below, test whether the mean pressure applied to the driver's head during a crash test is equal for each types of car. Remember, we have 3 types of car: the hatchback, the minivan, and the sedan. So when it comes here, realize that we have 3 types of car here. So we let our mu1 be the mean of the first car, mu2 be the mean of the second type of car, and the mu3 be the mean for the third type of car. So our null hypothesis will state that the 3 means will be equal. So that means mu1 is equal to mu2 is equal to mu3. So this is going to be our null hypothesis. And our alternative hypothesis is going to be that at least one of them is different. So this becomes the solution to the first part of the question. And remember that the second part of the question says we should find a test statistic. But before we can find for the test statistic, we have to use the Anova table, right? So let me show you how the Anova table looks like, a prototype of it. So this here is an Anova table. So Anova just means analysis of variance. So there's a type of it. So we have our source of variation, sum of squares, degrees of freedom, mean squares, and we have our F statistics. So as you can see here, so hardly are we asked to compute it manually. Mostly it's being computed for us. There are gaps in between and we have to fill them. And most of the times we use statistical packages to compute the Anova table. It's not something we usually do by hand. So we are going to also do that, and we are not going to do that by hand. So actually when we do that, we are going to get this, and this summarizes everything for us. So this thing here, but I'm going to show you how we did that. Alright, so realize that this is our data here. So we come here and we select our data. So after selecting them, then let me increase the font size. So after selecting them, then we come to data. When you go to data, we have data analysis here. If you haven't used data analysis before, you might not see it then, so you have to add it. When you go to data analysis, we come here, so realize that it is loading. Then we are doing Anova single factor, so we come to Anova single factor. Then we click on OK. So we have to select the range, so input the range. We come there, and the whole of this is the range. So that means we have to select everything. We come in. So we've selected the range. After that, we come here, then you realize that there is a label in our first row. Those are the types of the car. So we select that one and we go to OK. So when you go to OK, I hope you can see that now. So we have our Anova table here. There's our Anova table. So our Anova table is ready and we can see it here. So here, this is our sum of squares, our source of variation, our degrees of freedom, the mean squares, our F statistics. So this is the F statistics we are looking for, and it's the critical value. So you realize that when we did the ANOVA, it has given us our critical value here. It has also given us our F statistics, right? So that's how we do that analysis. So let's come back to it. So this is going to be our data, our table. So this is our F statistics and this is our critical value. So that means our F statistics is 25.1754 and the critical value is 5.14. So as you can see it here. Another way to calculate the critical value is to use your F table, and when you read it from the F table, you're going to get 5.14. Okay. Alright, then we go to the decision rule. So the decision rule is that we reject the null hypothesis if the absolute value of the critical value is less than the absolute value of the test statistics. You realize that our critical value, the absolute value of it is 5.14, which is still 5.14, and it is less than the absolute value of our test statistics, which is 25.1754. So that means that with this particular question, we are going to reject the null hypothesis. So we reject the null hypothesis since the absolute value of the critical value is less than that of the test statistics. So therefore, the interpretation of our result, therefore the mean pressure applied to the driver's head during a crash test is not equal for each types of car. I hope you get it. So thank you very much. This is the solution to the question, and please don't forget to like the video and subscribe to our YouTube channel once again. Bye.